Ignition systems. The ignition system provides a spark of sufficient intensity to ignite the air-fuel mixture at the predetermined position in the engine under all speeds and load conditions. For example, in a 4-stroke 4-cylinder engine operating at 3000 rpm, individual cylinder requires a spark at every second revolution, and this necessitates the frequency of firing to be 6000 sparks per minute or 100 sparks per second. This shows that there is an extremely short interval of time between firing pulses. Ignition system requirements. It should provide a good spark between the electrodes of the plugs at the correct timing. The duration of the spark must be long enough with the sufficient energy to ensure that the ignition of the mixture has a high chance of occurring. The system must distribute the same high voltage to each of the spark plugs at the same exact time in every cycle. It should function efficiently over the entire range of engine speed. It should be light, effective and reliable in service. It should have the ability to produce spark even when a shunt is established over the spark plug electrodes. May not cause radio interference. The development of high-speed, high-compression internal combustion engines requires a high reliable speed ignition system. This is met by a high-tension ignition system that uses a spark plug as the source of ignition. The electrical energy to the spark plug is supplied by one of the following systems and is termed accordingly: battery ignition system, magneto ignition system, electronic ignition system. Battery ignition system. The primary circuit consists of the battery, ammeter, ignition switch, primary coil, winding, capacitor and breaking points. The functions of these components are: battery provides the power to run the system, ignition switch allows the driver to turn the system on or off, primary coil produces the magnetic field to create the voltage or high voltage in the secondary coil, breaking points a mechanical switch that acts as a trigger mechanism, capacitor protects the points from burning out. The secondary circuit converts magnetic induction into high voltage electricity. The functions of components are: secondary coil, the part of the coil that creates the high voltage electricity, coil wire, a highly insulated wire to take the high voltage to the distributor cap, a plastic cap which goes on the top of the distributor to hold the high tension wires in a right order, rotor spins around on the top of the distributor shaft and distribute the spark to right spark plug and each and every time. Spark plug will also come under this circuit. Magneto ignition system. This is almost same as battery ignition system, except battery is replaced by a sort of a generator. The high powered high speed spark ignition engines like aircraft, sports or race car engines use magneto ignition systems. The basic components of a magneto ignition system are magneto, breaker points, capacitor, ignition switch, distributor, spark plug LEDs and spark plugs. Magneto can either be rotating armature type or rotating magneto type. In the former, the armature consists of the primary and secondary windings all rotate between the poles of a stationary magneto, while the second type, the magneto revolves and the windings are kept stationary. In electronic ignition system, the work of distributor is carried away by electronic control module. And there are different types of electronic control ignition systems, and we will look at all these ignition systems or advanced ignition systems in the later video.